Before I begin this exam review video with you, I want to remind you of something. Trig honor students, if you can believe, all things are possible to the one who believes. If you can believe, nothing's impossible to the one who believes. What's too hard for God? Did he not make the sun, the moon and the stars, the heavens and the earth? So if you can believe, nothing's impossible to the one who believes. All things are possible to the one who believes. Do you believe that? I trust you do, and that you believe that you can do well in this exam, because that's where it really starts. Those are not my words, those are Jesus's words. He says, if you can believe. So I want to start off with this one here, number 10 with you, where it says solve the triangle to the right. Write your answer to the nearest 10th place. In solving a triangle, you're going to be finding all the missing features. So be finding length A, hypotenuse length C, and this is one angle. So we're missing three features, two lengths, A and C, and the angle A. Angle A would be easy to find. So A, I'm sure you know that, would be equal to the sum of these two, and then you subtract that sum from 180. So let's take a look at that. 1 minute. It's going to be 180 subtract or minus 90 plus 26. So A is going to be equal to 180 minus 90 plus 26 is 116. Borrow 1 from the 8, leave us 7. That one makes this 10. 10 take away 6 is 4. 7 take away 1 is 6. And so we have this angle A will be 64 degrees. Alright, and now to find side length A, this is a right triangle or a righteous triangle. So we can go ahead and say, okay, since we know angle B is 26, we can use either SOHCAHTOA or TOA involving A, involving the 26, and involving, say, the 15, which is a length of AC. So look at it, we say, so what would really work? Would SO work? Sine is opposite over hypotenuse. The sine of 26 would be 15 over C. Yeah, we could use that to find C if we like. But let's go ahead and find A first. Cosine of 26 would be adjacent, which involves the A. A is the adjacent length over hypotenuse C. So we could not do it. Let me just show you why we couldn't proceed like that. Cosine of 26 would be equal to adjacent, which is A, over hypotenuse C. The problem is that we don't know A or C. We need to know two of the three in order to be able to do it. Okay, so we'll have to come back to that. Let's try the sine, which I mentioned before. Sine 26, this one is more promising, is equal to opposite, which is 15, over hypotenuse is C. So we do know 2 out of the 3 right now. So we can go ahead and find C. Let's do the cross multiplication. So we have C times sine 26 is equal to 15 times 1, which is 15. Divide both sides by sine 26, and we get C equals 15 divided by sine 26. And so in our calculators, we're working this out to the 10th place. I forgot to mention that. Go to our calculator. I'm going to get my calculator here. And I put in 15 divided by 26 sine equals, and I got 34.2. 34.2. I'd like you to do the same thing and confirm this in your own with your own calculators. 34.2. That will be length C. Let me just put that here. 34.2. And in order to find length A, since you already know this leg and the hypotenuse, you could just use hypotenuse. You can just use the Pythagorean theorem here, or we could just go ahead and use the cosine ratio. Let's do the cosine ratio for some more practice. Cosine 26 is equal to, as mentioned before, A over C. A over C, but we do know the C now. We just found it as 34.2. So when we do the cross multiplication, it's going to be a little bit easier because 8 times 1 is A. And that is going to be equal to 34 times 34.2 times the cosine of 26. So that would give us 34.2. Back to our calculators now. 34.2 times 26 cosine. I put the angle in first for mine. Most likely for yours, you'll put the cosine and then 26 in. My calculator is not as maybe fancy as yours is. So it's 30.7. I hope you can confirm that. 30.7 for A. 30.7. Okay, so that is the way you'd solve this right triangle using the trigonometric ratios. And sometimes, as I mentioned, you might set one up, and if you're missing 2 of the 3 variables, then you have to try something else. When you set it up properly, you'll have to know 2 of the 3 variables. All right? Go ahead and let's go to another type. Verifying the following identities. And here's where I'd like you to remember Colossians 3:4, which is the best identity you could ever have. And that is the scripture which tells us that Christ is our life. So he is our identity. And as we verify these, let's go ahead and bear that in mind. This one should be fairly easy for you. And I trust this one as well. So let's go ahead and do this one, number 13. Cotangent theta plus tan theta equals secant theta cosecant theta. And let's identify the side we're working with. This would be the left-hand side. And the tan, and I'm sure you remember, is the sine over the cosine. So it's sine over cosine. And that's what you really want to do whenever possible. Reduce everything to sine and cosine. Cotangent then would be cosine over sine. Put your theta in there and make it as sequential as you can so that I can follow step by step as you progress. What do you think comes next? I'm sure you're probably just there shouting, oh, Least common denominator. Yes, that's what it is. Cosine of theta. Sine of theta would be the least common denominator here. And in order to get cosine theta, sine theta, we have to multiply this by the sine of theta, in which case we multiply upstairs here by sine theta as well. Sine theta times sine theta will give us sine squared theta, plus to get cosine theta, sine theta, we'd have to multiply this denominator by what? It would have to be multiplied by cosine theta, in which case we have to multiply the numerator by cosine theta. Cosine theta times cosine theta is cosine squared theta. As you can see, we have sine squared theta plus cosine squared theta. This is going to be equal to, I'm going to go over here, 1 over cosine theta sine theta, which is equal to 1 over cosine theta. It's one factor. And the other would be 1 over sine theta. You already know what that is. 1 over cosine is secant, times 1 over sine is cosecant. And what do you know? That's the same as the right-hand side. Equals right hand side. Alright? So that's the way you do that. Very sequentially all the way down to where you get it equal to the right-hand side. So let's transition over now to finding the solution of equations. Here's one, number 14. We have an equation, pretty simple. Cosine of x is equal to the square root of 3 over 2. We're looking for the angle x, which would be such that the cosine of that angle is the square root of 3 over 2. I'm sure you know that would be a couple possibilities. Pi over 6, it's positive in the first quadrant, and also in the fourth quadrant, that would be I'm thinking 11 pi over something. You see 7 pi over 6. Yeah, how about 11 pi over 6? Yeah, that would be it. And that would be in the interval between 0 and 2 pi. So that would be the possible values of x. How about this one? Equation where sine theta is equal to negative root 2 over 2. Well, you know sine is positive in the first quadrant, the second quadrant. So this could not be first quadrant. Theta could not be second quadrant. Wherever you see, this should be a theta here I'm trying to make. Wherever you see root 2 over 2 is going to be some kind of pi over 4, 3 pi over 4, 5 pi over 4. And some of you, I'm sure, know that better than I do. It's going to be 5 pi over 4. This is the third quadrant right here. All right, it will be a fourth quadrant as well, which would be what? 7 pi over 4. So that would be solution for this, and you can work this one out yourself for practice. And let's take a look at this. A little bit more involved. 7 cosine theta plus 9 equals negative 2 cosine theta. This is just like 7x plus 9x equals negative 2x. So if we add the 2 cosine theta to both sides, and I can see the time is almost done. I'll make another video after this one to finish the review. So this one will give us 0 over here, and 7 cosine theta plus 2 cosine theta is 9 cosine theta. 9 cosine theta plus 9 equals 0. When I move over the 9, I get 9 cosine theta equals negative 9. Divide both sides by 9, I get cosine theta equals negative 1. So theta would have to be